that we understand all about oxidation numbers, let's take a look at how to identify a redox reaction using oxidation numbers. Okay, so consider the reaction carbon plus 2Cl2 gives me CCl4. Okay, so the first thing we need to do is let's assign oxidation numbers for each of the atoms that we see. So carbon is in its elemental state, so the oxidation number for carbon is going to be 0. Chlorine is in its elemental state too, so that's 0. Out here, we have to assume that chlorine is -1 because that's what the rule tells us, and we have to solve for carbon. Okay, so let's go ahead and set up an equation in X to solve for carbon. So we do X, I'll just go ahead and space this out a little bit. We'll do X plus 4 times -1, and that equals 0. So X minus 4 is equal to 0, or X is equal to +4. Okay, so therefore carbon is +4. So I'm just going to go ahead and erase the X and put a +4 out there, because now I have to use these numbers to kind of figure out what got oxidized and what got reduced. Okay, so as you can see, the carbon went from a 0 to a +4. Okay, so when the oxidation number increases, okay, so it's becoming more positive, that means carbon is actually, theoretically, it's losing electrons because it's becoming more positive. So therefore, that's my oxidation. And then chlorine is going from 0 to -1. So it's gaining electrons. So there's my reduction. Okay, so therefore, if we want to kind of sum this up nicely, increase in oxidation number is oxidation, and decrease in oxidation number is reduction. Okay, let's do another example. We have CH4 plus 2O2 gives me CO2 plus 2H2O. Okay, let's go ahead and assign oxidation numbers based on the rules we discussed. So out here, and I'm not going to go ahead and do the equation for everyone, but I'm going to go ahead and assign it, and then you can check with the equation with that I've shown you before. So that's going to be +1, and then this one is going to be -4, and then oxygen out here, it's in elemental form, so that's 0. Out here it's going to be -2 for oxygen and +4 for carbon, and then out here it's going to be -2 for oxygen and +1 for hydrogen. Okay, so once we have that, let's go ahead and try to figure out where is the oxidation and where is the reduction. So clearly carbon is going from -4 to +4, so that's an increase in oxidation number. So therefore there is the oxidation. And oxygen is actually going from 0 to -2, okay? So that's a decrease in oxidation number, so therefore that's my reduction. So out here, and then notice carefully, the hydrogen is not changing. See, +1 and +1. So nothing's happening to the hydrogen, so don't worry about the hydrogen. So what happened out here is the carbon actually got oxidized to carbon dioxide, right? So the carbon got oxidized and the oxygen got reduced, okay? And now if we try to figure out what's my oxidizing agent and what's my reducing agent, the one that gets reduced is always the oxidizing agent. So since the oxygen is getting reduced, this is my oxidizing agent. And the one that gets oxidized is the reducing agent. Carbon got oxidized, so that is my reducing agent.